welcome back to Financial Management course. Today would like to continue chapter 3, about time value of money, part 2. After studying chapter 3, you should be able to distinguish between an ordinary annuity and an annuity due, use interest factor tables, and understand how they provide a shortcut to calculating present and future values. Use interest factor tables to find an unknown interest rate or growth rate when the number of time periods and future and present values are known. Okay, we move to types of annuities. An annuity represents a series of equal payments or receipts occurring over a specified number of equidistant periods. Yeah, this is the keyword. Series of payment. Yeah. Actually, there are two types of annuities: an ordinary annuity and annuity due. For ordinary annuity is payments or receipts occur at the end of each period. The second one is annuity due. Its payment or receipt occur at the beginning of each period. So this is the difference. These are examples of annuities: student loan payments, car loan payments, insurance premium, mortgage payment, and retirement saving. Okay, this is the example of annuity or ordinary annuity. Just remember that for the ordinary, the payments occur at the end of period. For example, the period today is here, so the payment is start from here. This is year 1, at the end of period year 1, and this one is payment for year 2 and year 3. And then equal cash flow each one period apart. The same. This one parts of an annuity due. Just remember that for annuity due, it's the beginning at the beginning of period. The payment is at the beginning of period. So today is here, and the payment is at the beginning of period 1. Period 1 is here, and at the beginning of period 2 is here. The beginning of period 3 is here, and the equal cash flow each one period apart. This is overview of an ordinary annuity. Future value of annuity. Okay, we want to know future value of annuity. Just remember here, for I is interest rate, R is periodic cash flow. So every period, this one payment every period, at the end. R, periodic cash flow. Remember that for future value, we put timeline here. Periodic cash flow for year 1, year 2, and year 3. Put in the timeline here. And timeline and so for future value, is future value year 1 plus future value year 2 plus future value year 3. Yeah, here. Okay, for example here. Okay, cash flow occur at the end of period. Yeah, interest rate here is 7%. And periodic cash flow is $1,000 every year. This one, year 1, year 2, and year 3. So for future value is future value year 1 here. Okay. Here is 1,000 multiple 1 plus I or 7%, yeah, to the point of n minus 1, and here is 3 minus 1 is 2, yeah, equal to here. And then here plus R 1000 multiple 1.07 to the point of 1 is equal n minus 2 here. Yeah, n minus 2 here, so 1 plus 1000 multiple 1.07 is come from 1 plus 7%, where 7% come from is here. So 7% is 0.07, so 1 plus 0.07 is 1.07. 0 is from here. R plus R multiple 1 plus I to the power of 0. So future value of 1000 in year 3 is the same, 1000, yeah. Future value of 1000 here, year 2 is $1,070. So 1000 in year 1, if we put in year 3, is equal to 1145. And the future value annuity is total of future value year 1, year 2, and year 3. Is it clear? Jadi tahun ketiga, ya, yang dicari kan di tahun ketiga, uang $1.000 itu di tahun ketiga ya sama dengan $1.000 saat ini kan. Nah, uang 1.000 ya tahun kedua kalau ditarik ke sini nilainya itu setara dengan $1.070. Nah, ini $1.000 tahun pertama kalau ditarik ini mungkin tahun 2010, kalau di equalkan dengan tahun 2010, misalkan 2011, 2012, ya $1.000 2010 itu sama dengan $1.145 di tahun 2012. Ya, gambarannya seperti itu. Ya. Okay, next. Hint on annuity valuation. The future value of an ordinary annuity can be viewed as occurring at the end of the last cash flow period, whereas the future value of an annuity due can be viewed as occurring at the beginning of last cash flow period. This valuation using table, and the result should be the same. Okay, now we continue to overview of an annuity due. Yeah. Future value annuity due. This one, FVAD. Okay, this one is the formula. This is interest rate. This is periodic cash flow. Okay, for example, N is here. So this is the formula of future value annuity due. Yeah, see here. So this formula can be simplified here. Future value annuity due year N equal future value annuity N multiple 1 plus I. Yeah. This one multiple 1 plus I. Okay, example of an annuity due. So for example, cash flow, periodic cash flow is the same 1000 here, but the payment is here at the beginning of year 1, at the beginning of year 2, at the beginning of year 3. So the difference with previous is the time of payment. For the previous one is at the end of period 1, at the end of period 2, and at the end of period 3. For this one is at the beginning of period 1, at the beginning of period 2, and at the beginning of period 3. Future value annuity due. Yeah. This one future value here is 1000 multiple 1.07 and yeah 3, and this one 1000 multiple 1.07 and minus 1 is 2 here, and for this one 1000 multiple 107. Oh, this one is year 1, this one is year 2, this one is year 3. Yeah, this one is year 1, year 2, and year 3. Yeah, and the total for future value annuity due is $3,440. Yeah. You can also use this formula, future value annuity, multiple 1 plus I. So if you use this formula, so use this result 3215 multiple 1 plus 0.7, and the result should be here. This is valuation using table, and the result should be the same. Yeah. Okay, that's all about future value. Now we move to present value annuity. So this one is present value here. For future value is here, but for present value is here. Present it means now. Yeah. And this one is formula of present value annuity. Yeah. Present value annuity equal R per 1 plus I to the power of 1 plus R plus 1 plus I to the power of 2 until r per 1 plus I to the power of n. Okay, this is the example of an ordinary annuity or present value annuity. For example, periodic, it's the same. Yeah, actually the same example. Interest rate is 7% and periodic cash flow is $1,000. The same. The payment is occur at the end of period 1, period 2, and period 3. So for present value, we want to know here at the end of period 1, 1000 is equal with this one, 934.8 58. It's come from 1000 per 1.07 to the power of 1. And for this one, 1000 at the end of year 2 is equal, yeah, with at $873.44 here today, yeah, present, yeah. And 1000 in year at the end of year 3, yeah, it's equal if we consider interest rate, yeah. For present value is equal with 816.30. Where it come from? It come from this formula, 1000 per 1.07 to the power of 3. So the present value annuity is the total of this one. The result is $2,624.32. Okay, here on annuity valuation, the present value of an ordinary annuity can be viewed as occurring at the beginning of the first cash flow period, whereas the future value of an annuity due can be viewed as occurring at the end of the first cash flow period. This one, the example problem solution using valuation table, using table 4. And the result should be the same. Yeah. Okay, overview of an annuity due, present value annuity due. This is the formula of present value annuity due. R per 1 plus I to the power of 0 plus R per 1 plus I to the power of 1 until R per 1 plus I to the power of n minus 1. Or you should also use this formula, yeah, present value annuity due equal present value annuity multiple 1 plus interest rate, or 1 plus I. Okay, this one is the example of annuity due, present value of annuity due. The periodic cash flow is the same, $1,000. Interest rate is 7%. Yeah, so present value annuity due is this one, 1000 year 1, yeah, 1000 per 1.07 to the power of 0, yeah, it's equal to 1000 plus 1000 per this one is 1000 per 1.07 to the power of 1, yeah, it's equal to 934.58. And this one, yeah, equal, yeah, 1000 per, the formula for this one is 1000 per 1.07 to the power of 2. So present value is the total of here, and the result is 2802 dollars. Okay, if we use table, the result should be the same. Okay, this one step by step to solve time value of money problems. First of all, read problem thoroughly and then create a timeline. Then put cash flows and arrows on timeline and determine if it is a present value or future value. Yeah, for present, so we want to know the value of present, and for future, the value of future. And then number 5, determine if solution involves a single cash flow, annuity stream, or mixed flow. The next, solve the problem and check with financial calculator. It's optional. Okay, this one is mixed flow example. Julie Miller will receive the set of cash flow below. What is the present value at a discount rate of 10%? So interest is 10%. This one is cash flow for year 1. Oh, sorry, this one should be here. Yeah, should be like this, sorry. So this cash flow for year 1, this payment for year 2, year 3, year 4, and year 5. How much for the present value for this annuity? Mixed flow. Oh, because the number or the total is different for year 1, is different with year 2. Year 1 and year 2 is the same. Year 3 and year 4 is the same. For year 5 is different. Okay, how to solve this problem? There are some ways. First of all, solve a piece at a time by discounting each piece back to t equals 0. Or solve a group at a time by first breaking problem into groups of annuity streams and any single cash flow groups, then discount each group back to t equals 0. Okay, first of all, use piece at a time. I think it's easier. Yeah. Wait a minute. This one is year 1. This present value for the year 1. This present value here, present value for year 2. This one present value for year 3. So remember the formula is for this one is 600 per 1 plus 10%. Yeah. to the power of 1. For here is 600 per 1 plus 10% to the power of 2. Yeah. Use this formula. Wait a minute. This one. Yeah. And this one is 400 per 1 plus 10% to the power of 3. Yeah. And the total is $1,677.15 here. This is present value of the mixed flow. Now we can also use this one. Group at a time. Yeah. This one is 600 $600 for year 1 and year 2 is the same, and year 3 and year 4 is also the same. So group year 1 and year 2 plus group year 3 and year 4. Yeah, this one is loan. Yeah, year 5. Our result should be the same. Yeah. Yeah, this is using table. But actually I think this is easier than this one because you need to use table here. It is also use grouping. For this way, we put here 0, 1, 2, 3, 4 is 400 all, but actually year 1 and year 2 is 600, so plus this one 200 for year 1 and 200 for year 2. Yeah, and then present value each. Yeah, each group here you need to present value. And then for year 5 is just 100, so you need to present value here, and the total of all here is present value annuity. Mix. Yeah, mix flow. Okay, that's all for today. Thank you for your attention and see you.